Hi students, welcome to our physics class. Our chapter name is light. In the last few classes, we discussed about different topics in this chapter. And what we studied? First we studied about light. And then we studied light travels in straight line, light properties. Then we discussed about the mirror, that means the plane mirror. Plane mirror. After that we studied there are different types of mirrors are there. That means this plane mirror is one type. Another types are convex mirror and concave mirror. Convex mirror and concave mirror. These are the two types of another mirrors, that is convex mirror and concave mirror, and this is plane mirror. So after studying these types, we explained what is this convex mirror, what is this concave mirror, what are the difference between the images formed from this convex mirror and concave mirror. We studied simply. Now we are going to study in detail, and then we studied there are different types of images, that is virtual image. Virtual image is the real image is there. These are two types of images. What is this virtual image and what is this real image? Is it possible to focus the image on screen? Is it possible to focus the image on screen? Then that is real image. And when the image, is it possible to focus? Then it is real, and if it is not possible, then that is virtual image. That means, for example of our mirror, we can see the image is there on the mirror itself. For example, when we are looking on the plane mirror, then we can see our image is there on the mirror, and so that is virtual image. And the real image means we can focus it on screen. So these things we discussed in the last class. Now we are going to study in detail about the image formation of concave mirror and convex mirror. First we want to explain the activity for that. First we are going to study about concave mirror. Image formation of concave, image formation of concave mirror. This is our first topic. For that, first we need one concave mirror, then one object, one screen. These are the three things we need for this experiment. That means I am just taking one. What is this? What is the name of this mirror? This is curved inward. So this is concave mirror. And I am placing this on the stand. Placing this on the stand. And always I want to place the object in front of this mirror. That means we don't want to place the object here. If we are placing the, no use. So we want to place the object at this side, at the left side of this. So I want to place the object, and here I am selecting the object is a lighted candle. Lighted candle. And I have one screen. First I am just placing the screen at this point. That means the peculiarity of the screen is this. I can move the screen front, back, side. Like I can move the screen to anywhere. So this stand is having, this screen is having a stand. So I can move it to one place to another. So this is not fixed. And this is candle and this is our mirror. That is our concave mirror. Now we are going to start our activity. At first, we are placing our candle. Now I am going to call this as our object. I am placing our object very far. So when I am placing this object very far, then what happens? That is our question. Object at very far. So theoretically we can say the object is at infinity. This infinity means we are placing this object very far. So when we are placing this object very far, now the question, where we will get the image or how this image will be. That is it small, is it big, is it inverted, is it erect, like all the questions are there. Now we want to study that. Actually you will study for this. Actually it is having a particular name and the image will form at a particular point. Everything is there. But you will study this in detail in your 10th standard. Now you are only studying the outline of this. So we can say when we are placing the object very far, that means placing at infinity, we will get the image in point size. You will get the image in point size means very small. And the thing is this, you can focus that image on the screen. That means, what is the type of image? Is it real or virtual? It is real. Point size image, real image, and suppose this is our screen and you will get the image like this. Is it erect or inverted? Of course it is inverted. So real image and inverted. So the place is not this. I just show you one example. So we can say when we are placing the object at very far, that means when we are placing the object at infinity, we can say the image is very point size, very small. Then the image is real. That means we can focus that image on the screen and it is inverted. That means when our object is like this, our image will be like this. That is inverted. So this is the first place for our candle. And this is the first point. I think it's clear for you. Now, actually how we are getting this image on this screen? That we are getting this light is traveling. We know light travels in straight line and hitting on our mirror and then reflect back. And because of this, we are getting this image on our screen. And one thing is this, the light is not possible to pass from this. That means, what is this material? Is it transparent? No, this is not transparent. If we are using transparent material, what happens? The light will travel through this. So we can say this is mirror. That means it is opaque substance. No light will pass through that. So that's because the reflection occurs and that's how we can focus this image on a screen. That is the first point. Now we are going to move this candle to another place. Same activity, but when we are changing the position of this object, then we can see some sort of difference with the object. For the image. That means now I am going to place this candle here. That is, I am just moving this. Now this is not there. When this object is there, we got point size. Point size. Now I am just moving this candle to front. Now I am going to look what happens to the image. So when we are placing the object, here also it's far, but it's little more near than this. So we can write object at far. Object at far. Now you will get the image little more bigger than this. Now it is not point size, it is small. It is small but not point size. Little more bigger than this. So we can say small image. Small image. Then what about is it real or inverted? Yes, it is real and inverted. That means these two things are same for this and this. It is real, inverted. Real means we can focus it on screen. And it is inverted. That means our image is this and we will, our object is this and we will get the image like this. So we can say it is real and inverted, but the size is making little more big than this. That is the only difference when we are moving this candle from this point to this. Now the third thing is I am again moving this candle to front. Now here this is small. Now we are going to discuss the third point. Again I am moving this candle from this point to this. Now we want to check what happens. I already said that for our lens or for our mirror, it is having a center. I already discussed and said we are denoting it with capital C. Suppose our candle is there at C. That means for all the mirrors, is it concave or convex, it is having one center. Actually the thing is this, when we are completing this circle, we will get a center. So suppose, here only the suppose this is at C, what happens to our image? That is our question. We are going to discuss. So, object at C. Object at C. We are placing the object at C. What happens to the image? Now, the thing is very interesting. The size of the image is same as the size of our object. That means if the object is having 2 centimeter length, then our image also having 2 centimeter long. So we can say same size of object. Image is having same size of object when we are placing the object at C. The C is the center of our mirror. So now the question is it real or virtual? It is actually real. Real and inverted. So here also you can see for this all same, real and inverted. But the only difference is for the size of the image. So we can say this is same size. Same size. So we discussed 3 cases. Now again I am going to move this candle from this point to front. That we are going to discuss. So again I am moving this inside the C. Now this is the C, then moving this to inward C or inside the C. Again our candle is there. And now we are going to discuss object inside C. That means very near to C but inside. Now what about the size of image? Is it smaller or same? No. When you observe this, you can see that the size of image is bigger than this object. That means, suppose the size of the image is 2 centimeter, then you will get the image in the 5 centimeter or 3 centimeter like that. That means we can say it is enlarged or big. So, we can write the size of image is enlarged. Enlarged image we get from the object placed inside the C. And this is very near to C. And now what about, is it real or virtual? Is it inverted or erect? That we are going to discuss. This is inverted and real. The image is inverted and real. That means that is same for these four. All the images we get from these are inverted, real, but only difference is with the size of image. Here we get enlarged. So I am writing it here. Enlarged. Now again I am moving this to more closer to our mirror. We are almost end of our experiment. Now what happens? Close to mirror. Now the case is close to mirror. What is happening to our image? Is it small, same size, enlarged? What happens? What do you think? It is highly enlarged. That means suppose here we get the image of 5 centimeter. Then here we get the size of image is 10 centimeter. That means this image or this object give the image with a size of bigger than this. Little more bigger. So we can say highly enlarged. What is this highly enlarged? Highly enlarged means the image found from the object that is placed close to our mirror is highly enlarged. It is more enlarged than this. So we can write here highly enlarged. Very big. So, and what about the nature of the image? Is it real or virtual? Is it inverted or erect? What about that? This is also inverted and real. Inverted and real. So we can say for all these cases, for these 5 cases, our all images are inverted. That means when our object is like this, our image will be like this. That is inverted. And real means we can focus it on the screen for all these cases. And one more case is but its result is something different. That means when I am placing this candle very close to our image, for our mirror, when I am placing our candle very close to our mirror, what happens? Do we get the same result as inverted and the real image? No, you will get something different when you are placing the candle very near. And I am just trying to focus the image on the screen. Whenever or wherever I am moving this screen, I won't get the image on the screen. That means I can say the image is virtual. That is, when I am placing the object very near to the concave mirror, then I will get the image as virtual. That means it is not possible to focus the image on a screen. That is the first point. Next, you can see that here all we get the inverted image. And here you will get erect image. Erect image. That means if our image is like this, then you will get the result as the same. If our image is this, if our object is this, image also will like this. That is erect. Same direction. And now the only thing is left, the size of the image. Is it small, big or same size? What will happen? the thing is this, here also you will get enlarged image or highly enlarged, you can say like that, highly enlarged image. Highly enlarged. But the only difference that when we are placing the object very near to our mirror, then you will get virtual and erect image. For all other cases you will get inverted real image. And the only difference is this, the size of the image. Here it is point size very small, then it is big, little more big, again big, big, and here also it is bigger in size, but only here it is erect and virtual. This is the experiment for the image formation of concave mirror. In your 10th standard you want to study this as you want to draw the ray diagram and all, that you can study the. Now just understand what's happening inside this experiment. I think it's clear for you. Now we are going to discuss about the uses of our concave mirror. What are the uses where we are using this concave mirror? Uses of concave mirror. So the thing is this, normally we are using this concave mirror to enlarge the image. This is our aim, to make it enlarge. So we are using this in the torch, searchlight and vehicle headlight. Actually the thing is this, when we are using this, the light is getting spread. Or we can get the light as enlarged. That's why we are using this concave mirror in our torch, searchlight, vehicle headlights and all. You can see that in your textbook. Just take the textbook and look, and that you can see the image in the page number 182. That is the first use. We can use this concave mirror in the torch, searchlight, vehicles and all. That means we can see for the torch it is there, some sort of thing is there like this. Our light is here and we will place the glass. So this is our torch and this is the switch, and so we are saying the concave mirror is this, concave. So that's about that. And next we are using this concave mirror in the hospitals. In which hospital we are using this? For the dentist. Dentists use this concave mirror for what? They are using this concave mirror to see the teeth and all in big size. So you can see some sort of tools and all having the concave mirror fixed at the end of the tube. So the aim is this, they are just putting this on the mouth and you can see that the teeth will be in bigger size, and that also you can see in the textbook, that on the 182 top side. So that's why they are using this. Here also we are utilizing concave mirror, makes the image enlarged, bigger. Now the next use is this. We can use this concave mirror in our solar cooker. We can use this concave mirror in solar cooker. The reason is this concave mirror focuses the light and it makes the cooking easier. So just study these examples. We are using this concave mirror in torch, searchlight, vehicle headlight. Then we are using it in the dental hospitals, on our solar cooker, or we are using this concave mirror to enlarge the image or we are making it bigger. So that's all about this uses of concave mirror. I think it's clear for you. We said about the image we are getting enlarged. Now we are focusing on the mirror that we get on the vehicles. And when we are looking through that mirror, what is the size of the object and what is the size of the image? Suppose I am just placing chalk here. And what is the size of the image formed here? You can see the size is getting smaller. Or suppose I am just standing here, I can see my face inside our mirror in small size. And now the question is this, do this mirror is the same concave mirror? No. The mirror we are using in the vehicles are not concave mirror, that is convex mirror. Convex mirror. Now the same procedure we want to do for this convex mirror that we are going to do. For this here also we want the setup. Here I have the stand. I am placing the convex mirror. Convex mirror. And now the thing is this, I want to place the object. So I want to place the object here and also I have the screen. Now the thing is this, I am just placing this object somewhere, anywhere, far, near, like anywhere, and just trying to focus this image on the screen. Suppose this is our screen and I am trying to focus this, but the thing is this, it is not possible to focus the image on our screen. And for this case, that is the answer. It is not possible to focus the image on screen. Now I am repeating this by moving this candle from this point to near, far. Like I am trying this activity for different points, but for all cases it is not possible to focus the image on screen. So generally I can say image is not real, it is virtual. Virtual means it is not possible to focus on screen. Always you can see the image on this convex mirror. Image is virtual, whatever the position of the object. And next the question is this, is it erect or inverted? What about the vehicle mirrors? Do we are seeing the vehicles are inverted? No, we can see it erect. So the image is erect. Image is erect, virtual. And what is the size of the image? Is it big? No. We will get the image size is small. That means within that mirror we can see the whole vehicles, whole big buildings, all the things we can see in the convex mirror. So we can say the image is virtual, image is erect, small. That means comparing to our concave mirror, it is having the difference with the size of the image when we are placing it far, near, like the things. But for the convex mirror, there is having a single result. The result is this: image is virtual, image is erect, image is small. This is the only result. So you only want to study this and put it in your mind. Whatever the position of the object, all will get the same result. This is about our convex mirror. Now we want to study the uses of this. First use, you already know that we can use this in our vehicles. Uses of convex mirror. when we are using this convex mirror, we can see the vehicles that placed behind our vehicle. So that's about the first use. The second use is this. We can use the convex mirror in the big buildings and the malls and all to get the wide area view in a small mirror. So we can use this in the hallways, buildings and shops. The aim is this: for the security guard and all, they can see wide region or wide area in a small mirror. That's the aim. We are placing this convex mirror in such halls or buildings, shops, like that. So that's one of the use for this convex mirror. And one more use is this. We are using this in sunglass. Sunglass. The reason is this: for the concave mirror, it focuses the light. Here we know it do not focus image on a screen. Or in the similar way we can say, for the sunglass it will reflect back and don't get focused on our eyes. That means we can say the light is getting away from our eye when we are using sunglass using the convex mirror. So generally we are using the sunglass in convex mirror, and also we can use in hallways, buildings, shops and vehicles. We are using this convex mirror. So these all are the uses for the convex mirror. Now you just want to observe what are the other uses of our concave mirror and convex mirror. This is the work for you today. And in the next class we will discuss about the lens. Do we are seeing this convex mirror or concave mirror on our magnifying glass? No. That we can discuss in the next class. That means we can continue the topic within this chapter in the next class. So it's enough for today. Thank you.